Now, after studying the IUPAC naming, isomerism and all, now today we are going to study about a new topic, that is some new fundamental concepts coming in organic reaction mechanism. So, we are going to study about the basic concepts coming under the reaction mechanism, organic reaction mechanism. And here mainly we are going to study about the fission means what? Breaking or cleavage of the covalent bond or present in organic molecules. Now, we know that how we are generally representing a chemical reaction, any chemical reaction, how we can represent it as, yes, reactant or reactants reacting to give product or products, means they can be one or more than one reactants undergoing reaction to form one or more than one products, isn't it? But when we say about an organic reaction mechanism, or when we say about organic reactions, one of the organic molecule or it reacts with an appropriate attacking reagent. That is a new term that you are studying. The organic molecule will react with suitable or appropriate attacking reagents that we will see in detail. So, they will react with attacking reagents, and first they will be forming, before they form products, first they form some intermediates, reaction intermediates, and these intermediates are always highly unstable. So, being highly unstable, they will readily decompose to give products. So, how we can represent an organic reaction generally as it is the organic molecule. Okay. So, in organic reaction, the organic molecule which is undergoing chemical reaction will be called as substrate. Then on what basis it is called as substrate? Here we are not using the term reactants. Instead of reactants, we will be using the term substrate and attacking reagent. Both will be coming as reactants, but one will be called as substrate and the other one will be called as attacking reagent. Then on what basis we are calling the molecule as attacking reagents and as substrate? We know that during every chemical reaction, whether it is an inorganic reaction or organic reaction, there will be breaking of old bonds and formation of some new bonds taking place, isn't it? But when we say about organic reactions, we know that an organic molecule means the main skeleton present is. What is the basic structure present in an organic molecule? Yes, it is the carbon skeleton. So, during an organic chemical reaction, there will be breaking of old carbon-carbon bonds, or sometimes there will be breaking of carbon and some other atoms bond like carbon-oxygen bond or carbon-halogen bond or carbon-nitrogen bonds, etc. And there will be formation of new carbon-carbon bonds or new bond between carbon atom or some other atoms. Okay. So, during this bond breaking and bond formation, the molecule which supplies carbon for the new bond formation will be called as substrate. Okay. So, among the reactants, the molecule, the organic molecule which can or which supplies carbon for the new bond formation will be called as substrate, and the other molecule or the other reactant will be called as the attacking reagent. Okay. But there are cases where both the organic molecules or both the reactants will be able to supply carbon for the new bond formation. In such cases, when we study that organic reaction or that particular organic reaction, the reactant or the organic molecule in which more attention is paid or more attention is focused will be called as substrate, and the other one will be called as the attacking reagent. So, this is about the reactants coming in organic reaction. So, one of the reactant will be called as substrate. So, that substrate or the organic molecule that will be reacting with an attacking reagent. So, there will be a suitable or appropriate attacking reagent for each and every organic reaction. Now, after that they will form highly unstable intermediates. Intermediates are highly unstable. Highly unstable means they are highly reactive species, isn't it? So, being highly unstable, that is why it is written inside the square bracket. So, if there is anything written inside the square bracket means that is highly unstable. So, here first they will be forming the highly unstable or the very reactive intermediates. So, being highly unstable, they will readily decompose to give stable product or sometimes products. Okay. So, now along with products there can be byproducts also during some reactions. So, this is about the general representation of an organic reaction. So, remember here we are using, instead of reactants, we are using the terms like substrate and attacking reagents. Now, what is meant by a reaction mechanism? What is meant by a reaction mechanism? We know that there are certain reactions which can take place in one step, but there are reactions which are taking place in 2 steps. But certain reactions are taking place in 3 steps or more than 3 steps. So, what is meant by reaction mechanism? So, the definition for a reaction mechanism is a sequential account of each step describing the details of electron movement, because we already said that during every chemical reaction, whether it is organic or inorganic, there will be formation of new bonds and breaking of old bonds. So, mechanism will describe the details of electron movement, then energetics during the bond cleavage as well as the bond formation. Bond cleavage means bond breaking, and the rates of transformation of reactants into products. Rate of reaction means kinetics of reaction or speed of reaction. For example, if a reaction is taking place in 2 steps, we cannot say that the 2 steps will be taking place with the same speed or same rate. Sometimes the first step will be fast and second step will be slow, or first step will be slow and second step will be fast. So, this is about the rate of each step. So, explaining all these things is referred to as what? Reaction mechanism. So, this is about the definition for reaction mechanism. Now, we will see fission of a covalent bond. We know that covalent bond in organic molecule there is formation of carbon. The basic skeleton is formation of carbon-carbon covalent bonds, isn't it? So, how the fission, or what about the breaking of a covalent bond in organic molecule? There are mainly 2 types of fission or cleavage or breaking taking place. The first one is known as homolytic fission and second one is known as heterolytic fission. Okay. First we will see what is meant by homolytic fission. This homolytic fission actually takes place mainly in the presence of high energy radiations like UV radiations or in presence of heat. So, high energy is required for homolytic fission. So, first we will see what is this homolytic fission. Take the simple example of just for example, if a covalent bond, if it is formed between 2 similar atoms, that is A. We know that a single bond is representing what? A single bond means it contains how many electrons? 2 electrons or 1 pair of electrons, and this is called as what? Shared electrons, isn't it? So, here if there is high energy radiation like UV radiation, so we can write it as H nu. H nu is representing what? Light energy, okay. Or in presence of heat energy, both are not required, any one is actually required when we write the equation. So, homolytic fission takes place in presence of heat or light. So, in presence of heat or light, what happens to this covalent bond which is between two similar atoms. Here what happens is that here the bond is between two atoms of A. So here this shared pair of electron breaks in such a way that each atom takes one electron. So see how I am representing? I am representing by, I am not using complete arrow, I am using only half arrow, and one of the electron will be taken by the next atom. So each atom is taking one electron from this shared pair. Shared pair means a pair means two electrons. From this two electron, one atom will be taking one electron and the other atom will be taking other electron. Which are the atoms? The bonded atoms. Okay, so bond is between two atoms of A. So each atom will be taking one electron. And what will be the product of this reaction? So if they are taking one electron, what happens? They will be breaking of this bond or cleavage or fission of this covalent bond. So what happens? They will become two independent atoms with this atom will be getting one electron and this atom also, A atom will be having one electron. Either you can draw dot or you can use cross, okay, to represent this electrons. Okay. So each atom is getting an unpaired electron. Getting one electron means what? Not paired. That we can call it as unpaired electron or getting odd electron. And such species are known as free radicals. So homolytic fission results in the production of neutral species. If how or when an atom is getting or when any species is getting negative charge, if it is gaining a pair of electrons. So here they are not gaining a pair of electrons. Here they are getting only one electron each. So they are actually called as free radicals. So homolytic fission results in the production of neutral species carrying odd electron or unpaired electrons called as free radicals. So how we can define this homolytic fission as? It is the breaking of a covalent bond. How it is breaking? In such a way that one of the electrons of the shared pair. So from shared pair, one electron of the shared pair in a covalent bond goes with each of the bonded atom. That means each of the bonded atom will be taking one electron. So they will be breaking off that covalent bond. And there is movement of a single electron. There is movement of single electron only. That is clear from this equation. And there is movement of only one electron towards each atom. That is why we are using only half arrow. This arrow, what is the structure of this arrow or what is the shape of this arrow? This is half-headed arrow, not complete arrow, half-headed arrow, or we can say that it is a fish hook-like structure. Now it is represented by this arrow, half-headed or fish hook-like arrow, and it takes place only in presence of heat or light because it requires such fission, because we are breaking the bond at the center. Okay, so it takes place only in presence of heat or light because such fission requires high energy. And it results in the formation of neutral species which contains an unpaired or odd electron called as, such species are known as free radicals. One more example we can see. For example, ethane. Ethane, we know the formula is CH3CH3. In presence of, here I am writing light only, in presence of light radiation, what happens? They will be in presence of heat or light. Remember always what fission will be taking place? Homolytic fission. So here we know that a single bond means two electrons. a single pair of electrons. So in presence of light, what happens, this covalent bond is actually between this carbon and this carbon. So here one carbon will be taking one electron from this shared pair, and this carbon also will be taking this electron from this shared pair. So finally what happens, they will be breaking off this carbon-carbon single bond or covalent bond, and it results in the formation of what? CH3. It will become two separate CH3, because now there is no bond between two carbon atoms, and this carbon will be getting one electron and this carbon also will be getting one electron. And what is the name for such species containing odd electron? Free radical. And what is the name of these free radicals? Yes, it is actually, what is CH3 group known as? Methyl group. So this is methyl free radicals. The better if you put dot. So in this board it is difficult to put the dot. So here and there you can see so many dots, so it will be confusing for you. That is why I have used cross. So when we write the notes, better put dots to represent the electrons. Now we will see one more example. CH3, CH2, CH2, CH3. In presence of, here I am writing heat. So here what happens is, here also we know that a single bond means two electrons. So if the splitting is taking place at this position, how it will be? This carbon will take one electron and this carbon also will take one electron. Finally they will be breaking off this carbon-carbon bond, and it will result in the formation of CH3, CH2 dot. This carbon will be getting one electron, dot or cross, whichever you want you can write. Then write from here, or you can write it as CH2, or better you write it as CH3, CH2 dot. Remember, the dot is on CH2 carbon because the breaking is taking place at this position, or if the breaking is taking place at this position, accordingly the radical will change. So here which free radicals are produced? What is CH3, CH2 known as? Ethyl. So here it is ethyl free radicals. Okay, so this is about the homolytic fission taking place in presence of heat or light. And next is about heterolytic fission. So in homolytic fission, we have seen that in most of the cases the bond will be between two similar atoms. It is not necessary. There is homolytic fission of a covalent bond which is formed between different atoms also. So here let us see a covalent bond which is formed between two different atoms. Two different atoms means more what? They differ in the electron negativity also. So here take the example of a molecule AB. So bond is between A and B. The first condition is the B atom is more electronegative than A. If B is more electronegative than A, what will happen? B will be having more tendency to attract the shared pair of electrons towards itself. So here how the fission is taking place is, the more electronegative atom will be taking both the shared pair of electrons towards itself. So what happens here? Since B is more electronegative than A, B will be taking, we know that a single bond means two electrons, so B will be taking both the electrons. So the bond is completely shifting towards B. So I am using complete arrow to represent heterolytic fission. So if B is taking both the electrons towards itself means, if B is taking both the electron means, now there is no bond between A and B, isn't it? So they will split as A and B separately. So A is losing electron because it was actually shared pair of electrons, isn't it? So if B is taking both the shared pair of electrons, A is actually losing electron. So A will be getting a positive charge. and B will be getting negative charge. So remember, in organic chemistry, any atom getting negative charge means the negative charge is actually representing how many electrons? 2 electrons. Clear? So negative charge representing how many electrons? This you have to keep it always in your mind. Negative charge means how many electrons? 2 electrons. Now, if in the same molecule, if A is more electronegative than B, what will happen here? Yes, so here also we know that the covalent bond between A and B, single bond means a pair of electrons or 2 electrons. If A is more electronegative than B, A will be taking both the electrons. And finally here also what will happen? They will be breaking between A and B. Now they are separated. Now A is getting a pair of electrons means A is getting a negative charge. So remember once again, negative charge means 2 electrons. And B is losing electrons, that means B is getting positive charge. Now see here, after the this type of fission is known as heterolytic fission. Each atom is not getting same number of electrons. One atom is getting and the other atom is losing. So such fission is known as heterolytic fission or heterolytic cleavage. And see the products after the heterolytic cleavage, we are getting positively charged and negatively charged species. So how we can define heterolytic cleavage as? When a covalent bond joining two atoms break in such a way that both the electrons of the covalent bond are taken away by any one of the bonded atoms. Okay. Now, it takes place when a covalent bond is formed between different atoms differing in the electronegativity. It is always represented by complete arrow. Okay. Either in any one direction we can draw. It will be always pointing towards the more electronegative atom, and it results in the formation of positively charged and negatively charged species. This is about the fundamental, the basic type of how the fission is taking place. The fission of covalent bond is taking place during a chemical reaction.